Okay, hi there. We are picking up on law of cosines. Got a couple things that we have to clean up after today's lesson. So if you recall, just kind of a review of what we did today, using the law of cosines, there are three forms of the formula for the law of cosines, depending on which sides of the triangle that you're using. But it really is one and the same law. But if you will, you can see that if I'm looking for side A, then I'm going to use angle A in the cosine function. If I'm going to look for side B, I'm looking for cosine B. I have that cosine of the angle B in the formula. And then if I have side C, I have the angle C in the cosine part of the formula. And remember today we talked about that, hey, in that last one especially, it rings true that if angle C is 90 degrees, we see that we have our Pythagorean theorem, C squared is equal to A squared plus B squared. Oh, I'm missing a little 2 there on the square. So we did a couple problems there, solving for a part of the triangle, finding the sides, and we did 2 problems there where we were looking for, and we labeled the parts of the triangle A, B, C, just so they would mirror the formulas that we were using. So we did a couple problems like that. You guys did the last one, and you did a great job, star for you. Star stickers. And so then we moved on after that to finding the angles. So finding the sides was kind of a direct, we're finding the side C, so we put all of the missing values. Remember, you have 4 variables in the equation, A, B, C, the sides, and then another angle. So you have 4 variables. You can substitute 3 of them and solve for the 4th, and that's essentially what we did. Finding the side, we're only working with the right-hand side of the equation, and once we simplify that, we get our answer. Whereas now we have the cosine of the angle to consider here. And what I showed you in the first step, it's not necessary that you do this, but you can write a formula to solve for the cosine, solve for the angle itself, especially if maybe you were asked to do that for several problems and you just want to write the formula down. There it is. But you can always substitute into the original form, and we do some of the problems like that. But there you go. There you have it. We have turned out that we have to use the inverse key on the calculator, where you do the second cosine and then get your angle then from that. You have the cosine of the ratio, cosine inverse of the ratio, and get the angle. Okay, and then we did another problem where we got the angle. Notice that what I did here, though, different from the first one, is that I didn't use the formula for cosine A, or solving for the angle, cosine of the angle, but I plugged right into the formula the way it's written, and then got cosine X is equal to the constant in the end, and then got our value X for the angle. Okay, and there's another problem that we did where we have the 3 sides, and once we where we have the 3 sides, we're looking for the angle R. So you can see that the equation form that I used is that I used the lowercase r squared on the left-hand side, the uppercase r as being the angle on the right-hand side, and then I named the triangle, set it up. So that's very helpful to set up the triangle in these situations. But I wanted to send you a short video on how to handle these problems. 2 ships leaving at a port. Well, here's the port right here at 8 a.m. And so notice the setup. You're talking about bearings. So you have to get your bearings, so to speak, that north goes straight up, south goes down, right? So there's the north and south of it. So it says that both of them leave at the port at 8 a.m. Ship A sails with a bearing of 68 degrees east. So when I first drew that, let me put the blue highlighter on this. So the 68 degrees is the angle going from true north 68 degrees east. So with that, I have that right there. North, so where'd it go? Over here, 68 degrees east. So it's kind of like when it says north 68 degrees east, it's bending that way. Go straight up north and then bend it over 68 degrees to get to your 102. I'll get to that in a second. And then for the 35 degrees east, it going south. And then you can see here, 35 degrees east from south, you get that angle out. And here's the side of ship B. That's the pathway for each ship A and ship B. Okay, now you're being asked, and you're being told that the ship A is sailing at 17 miles per hour. So I kind of listed that right here. Ship B is going 12 miles per hour, right? And then the ships maintain their paths. How far apart are they at 2 p.m.? So, you kind of notice that they started at 8 a.m. and then at 2 p.m., this is when they get to this point at 2 p.m. So each of the respective ships are here and here, right? Sometimes you get a lot going on in a diagram and you can redraw it as I did in the next problem, but it's all right. So in this case, we want to find out how far apart they are. And, it's kind of easy. The first thing I do is I find, well, what is that angle big X there? So it turns out that capital X, the angle, turns out to be 77 degrees because the straight line is 180 degrees. And so we solve for X. We get the angle X has to be 77 degrees. Then once we have that, then we can set up our law of cosines, but we're really missing something. I'm sorry. The next thing we have to do is we have to find out what kind of distances. We want to know this X distance. This is a distance. How far apart are they? That X distance, we need to have our expressions in terms of distance. So we have 17 miles per hour times 6 hours and 12 miles per hour for times 6 hours, respectively, for ship A and ship B's distances. And you can see I've labeled the diagram with 102, and that's in miles, and 72 miles also. Now we have the distance plug into the formula, and that's our step 3. Okay, we get 110.8 miles, and there's our winner chicken dinner. Okay, so here we go. Now, bearing measures the acute angle that a path or a line of sight makes with a fixed north-south line. Okay, so here's what we did for the next one. Bruno, and we can't talk about Bruno, but we'll talk about him for just a minute. And Aliona are figure skaters. Starting from the same location, Bruno skates 29 feet at a bearing of south, 59 degrees, 9 minutes west. So you see where I have that labeled here? So it's south, and then it's leaning west, right? Right? And then Aliona skates 18 feet, so that's 29 feet. I have that marked here too. 18 feet at a bearing of 16 degrees, 51 minutes east. So you can see that I have that here, and there's her 18 feet. Aliona's 18 feet. And you want to know, in the end, how far is Bruno from Aliona? So essentially what I did is I set up a new triangle because I was getting a lot of things going on. So the next thing that I did, I set that up, and I didn't know the 72 degrees, but I was about to figure that out. So in step 2, I said the angle between Bruno and Aliona's paths was the sum of 55 degrees, 9 minutes, and 16 degrees, 51 minutes. So I added them together, and I got this, which is 72 degrees. So I marked that then 72 degrees. And essentially what you want to do then, and simplifying the diagram, you go, oh yeah, I just want to find X here. So I set it up solving for the side X, and then I had X squared is equal to 29 squared plus 18 squared, plugged it into the law of cosines nicely, and I got 29.0 feet. Okay, and there's the answer to the question. Bruno was 29.0 feet from Aliona. And then the last one. The last one seems like it's a little hectic, but it's really not that bad. The helicopter spots 2 landing pads below. So helicopter, here it is right here. I didn't draw anything, but I guess I could draw a little, like, kind of, here's a little helicopter, and here's there's the helicopter up in the air, right? So it spots landing pad A and landing pad B that are 20 miles apart. Fine, and then it says the helicopter is 14 miles to landing pad A and 8 miles to landing pad B. So we have that marked also. Here's the helicopter, and you can see here's this line, and then here's this line. Okay, so it'll fall right in line there. Okay, so we have all the information we need, but the last statement says, if the landing pads are 20 miles apart, find the angle of depression from the helicopter to landing pad B. So this is what I'm looking to find here, this one here. But then noting that here is the horizontal, there's kind of what we call a principle of charity, that we're not going to deal with a situation that's really off, so to speak. We're going to accept some things. So here's a horizontal here, down here, parallel to the horizontal for the line of depression. So this is your angle of depression, right? angle of depression. It's below the horizontal, and then this 8 miles there is the line of sight, okay? So remember, the angle of depression is between the horizontal and the line of sight, and there you have it, x. So what we have, again, is a triangle. So we've got this triangle, and then we can say, all right, well, we've got this x, we've got this x down here that is congruent to the angle of depression. So we have an x here, and we are being asked to find that x. But we've got the 14 miles here, and we've got the 8 miles here, 8 miles, and then we know this is 20 miles. So I want to use, let me get some purple going on here. Let's get some purple. I want to use the included angle and the sides that surround it. And then I'm going to have to find, when I put this in, notice I plugged in the 14. I just plugged it into the equation. 14 squared is equal to 8 squared plus 20 squared minus 2 times 8 times 20 cosine x, and then I can solve for x. So just going down through each of the steps as you will look at and evaluate, then I get cosine x is equal to 0.8375, and I ran through this pretty quickly. If you find a mistake, I hope you do. That's always fun. No, I hope you don't. I hope that I ran through this pretty quickly, but I think I got it all. It turns out that x is equal to 33.1. X is equal to 33.1. Okay, and that is the answer to the problem. All right, and with that in mind, that'll be the end of my short lesson to go over these few extra problems. I hope it was helpful. And that will finish up our law of cosines lesson. So I hope you guys have a great night and get your homework done, and I'll see you tomorrow. Have a great one. Bye.